Hello everyone, welcome to this series of lectures on the course Foundations of Mathematics. In this lecture, I will talk about the graph of inverse of a function. So supposing I have a bijective function with me, let f from some set A to a set B be a bijection. Now because this is a bijection, f inverse will exist and will be a bijective function from B to A. Right? That's what we saw in the last video. So f inverse will definitely exist because f is a bijection, right? And this f is a function. So I can draw its graph. By definition, what is the graph of a function? Graph of this function is set of all ordered pairs of the form x comma y such that image of x is y. Okay, and these pairs, they are coming in fact from the Cartesian product A cross B. So I can mention that as well. So this ordered pairs in the set A cross B such that f of x is equal to y, right? So that's the graph of this function f. That's how it is defined, and you can plot this graph in the Cartesian product plane. Then supposing I have a point which lies on the graph of this function f. Okay, so let me take one point, let's say a comma b. It belongs to the graph of this function. That means it lies on the graph of this function. When will this happen? A point a comma b will lie on the graph if and only if f of a is equal to b, that is image of a is b under the function f, right? So this will happen if and only if f of a is equal to b. And in the last video I did a result which said if f is a bijection, then f of a will be equal to b if and only if f inverse of b is equal to a, right? So f inverse of b will be equal to a. This we have already seen. That means image of the point b is a under the function f inverse. So the point b comma a will lie on the graph of the function f inverse, and that is if and only if the point b comma a lies on the graph of f inverse, right? How is graph of f inverse defined? I can write it here. It is collection of all the points p comma q in b cross a now, such that f inverse of p is equal to q, right? So a point a comma b will lie on the graph of the function f if and only if the point b comma a lies on the graph of the inverse of that function, right? So that's what we conclude from here. And now if you see, what is the relation between the point a comma b and b comma a? Is there any relation between these 2 points? Supposing I draw the xy plane, let's see where this points will lie. Supposing the point A is here and the point B is here. See. Okay, approximately I'll just mark this distance as A comma B. Then where will the point B comma A lie? On the x-axis, B will be somewhere here and A will be more or less here, right? So that will be here. My diagrams are not correct. I mean, they are not accurate enough. But what is the relation between A comma B and B comma A? This point B comma A will be the mirror image of the point A comma B. Okay, if you look at this line x equal to y, that will be here, then this point B comma A will be the reflection. I'll just make it look like a reflection. So let's say B is here and B comma A will be here. So the point B comma A is nothing but the reflection of the point A comma B about the line x equal to y, right? So this is the line x equal to y, and if A comma B is here, B comma A will be here. It will be the mirror image of A comma B with reference to this line x equal to y, right? So what will be the connection between the graph of the function f and the graph of the function f inverse? The graph of f inverse will be the mirror image or the mirror reflection, you can say, about the line x equal to y of the graph of the function f. Okay, so if you say this is the graph of your function, then I'll just draw a rough one. If this is the graph of f, the white one, then the graph of f inverse will be somewhat like this. Okay, so it will be the reflection of the graph of f about the line x equal to y. I hope that's clear. Now let's see some I have plotted some graphs of some functions along with the graph of their inverses. So I will show you all the graph and I will show you all how exactly it's the mirror image of the function. Okay, so let's have a look at that. Look at this graph of the function. I have plotted the graph of the function f of x is equal to x cube. You can see my cursor, and the graph which appears in red is the graph of the function f of x equal to x cube. Okay, and its inverse is x raised to 1 by 3, that is the cube root of x. And if you see the graph that is coming in blue here, that is the graph of the inverse of the function f. And this line in between is the line x equal to y, which is passing through the origin here, x equal to y. Now if you compare the graph of the function f and the function f inverse, that is the inverse of f, you can see that it is just a reflection of the function graph of the function f about the line x equal to y, right? So that's how the graph of inverse of a function behaves. It's the mirror image of the graph of the function about the line x equal to y. All right, so one more function is this one, exponential. So if you plot the graph of the exponential function, then you will see that it is somewhat like this, the red line that you can see. Okay, that's the graph of e raised to x exponential function. This line passing through the origin is the line x equal to y, and the blue graph that you can see here is the inverse of the exponential function, that is log x. Okay, and again you can see that the graph of the inverse is the reflection of the graph of f about the line x equal to y, right? So I can zoom it a bit and you can see how it appears, right? So that's how this graph of f inverse behaves. Then one more that I've plotted is this example I had done in the last, I think in the last video. If you take the function f of x to be equal to 5x minus 7, then this straight line is the graph of that function, the red line that you can see, right? And its inverse turns out to be x plus 7 by 5. Okay, x plus 7 by 5, and the blue line is the graph of the function f inverse, and x equal to y line is here passing through the origin. And again you can see that the graph of f inverse is the reflection of the graph of f about the line x equal to y. Okay, so that's how the graphs of inverse functions behave. They are mirror reflections of the graph of the function itself about the line x equal to. Alright, so that's it for this session. These are my references. Thank you.